Awesome. So lovely warm-up problem here. Hopefully I managed to make something that factored. I don't know, did you get it to factor? Yeah, okay. So I was hoping I made something that factored. So if I look kind of first shot here, I'm thinking about what's the greatest common factor that I can pull out? What do they all have in common? So that's what I'm going to pull out first. And then I'll have 3x squared plus 4x minus 7. And from there, we can choose, are we going with an x? Are we going with thinking about factors? Let's go x because that's what I feel like right now. Totally up to you. So the thing that I'm going to put on the bottom is the 4 because that's what I need my terms to add up to. And the thing that I'm putting on the top is the 3 times -7 or 21. Sorry, -21. So I need 2 factors that multiply to be -21 and add up to 4. I think this pen might just be out of ink. It's like my favorite one. So I'm going to be sad if it stops working. But we need to multiply to -21, add to +4. So in terms of factors of 21, there aren't a lot. 7 and 3 are definitely the ones I'm thinking about here. And I know one has to be positive and one has to be negative. I need to end up with a +4. So that means my 3 has to be negative. So now if I were doing this, I would take this extra step. So we've got that x and I've got 3x squared, but I'm going to take that 4x and write that as plus 7x minus 3x and then minus 7. You could also put those the other way around. You put the -3 first and the 7 second, doesn't matter. Now I'm going to do the factor by grouping thing. So I'm looking at these two as a group and these two as a group. So from that first piece, the only thing they have in common is the x. So I would pull out an x, still have that x out front, but I'd pull out an x here, and then I'd have 3x plus 7. Now from the second two, I could just pull out a 1, but remember the idea with factoring by grouping is that I'm going to end up with 2 things in parentheses that match. And the only way I'm going to do that over here is if I actually pull out a -1. And if I pull out a -1, then I will end up with 3x plus 7. Now remember, the whole idea with factoring is that if I were to multiply that back in, I should sort of get back to what I started with. So that's why if I distribute the -1 in, I'd get the -3x and the -7. Next step, I look at my 2 groups and I say they both have this 3x plus 7 in common. So I'm going to pull out that 3x plus 7. And then from the first piece, I'm just left with the x. And from the second piece, I've got that -1. And that would be my final answer of this is the completely factored form. Questions about that? Yes. It would not. Let's see what happens. So let's see what happens if we had switched them the other way. Now, if you make the wrong one negative, that will give you a completely different answer. But if you just write them in the other order, it still totally works. So if I had written this step as 3x squared minus 3x plus 7x minus 7, we're going to get the same answer in the end. So I'm going to think about my factoring by grouping. So I've got these two groups. And from the first piece, I just like my colored pens, I'm not going to lie. From my first piece, the 3x squared minus 3x, I can pull 3x out of both of those. And then I'd be left with an x minus 1. From the second group, what they have in common is a 7. If I pull that 7 out, I've got x minus 1. So now when I go to do that like second round of factoring, these both have an x minus 1. So that's what I would pull out. From the first piece, I'm left with a 3x. And from the second piece, I'm left with a plus 7. So they're the same. They're multiplied in a different order, but this is the same factors in a different order. So the cool thing is you kind of can't mess it up, right? Like if you got the right factors, if you found the correct two numbers here that multiply to be that thing on the top and add to be the thing on the bottom, this is going to work no matter which way you happen to write the factors down. Other questions? Oh, yeah. Okay. So there are kind of different ways to write this in. I try to just focus on the numbers. But the whole point of what we're doing here is that the numbers in the middle is how I'm going to break apart the 4x. So I'm breaking apart the piece in the middle with these. So instead of just writing 4x, I'm going to think about that 4x as being a positive 7x minus a 3x. And remember, this isn't the only option for factoring it, right? Any way that you correctly get this factored is totally fine. So let's say that you had that x out there. I'll slide it up in just a second. If this whole factoring by grouping thing isn't working for you, you don't have to use it. We can also just look at this and think about, okay, if this is going to be two factors multiplied together, in order to get 3x squared, my only options are to have a 3x and an x. Now I have to look at what would I multiply together to get 7. Well, there's only one way to get 7, to multiply 7 times 1. But because it's a negative number, and because these two are different, right, I can think about a 1 and a 7 or a 7 and a 1. I know that they have to have opposite signs, like the 7 and the 1 will have to have opposite signs, but that plus tells me that the 7 is the one that has to be positive. And then I just try putting them in. So if I tried putting in the 1 and the 7, so that I had 3x minus 1 times x plus 7, when I distribute that out, I'd end up with a negative 1x and a positive 21x. So this doesn't work. So then I'd try my other combination with a positive 7 here and a negative 1 here. And now if I distribute that out, I'd have 7x and negative 3x. So this one works. So this is sort of like trial and error with your possible factors. And if you're quick with multiplying things, this can be more helpful or just sort of work better for some people. It doesn't matter at all to me, and it won't matter at all when you're taking calculus, which version of that you go for. Any way you want to get it factored will work. I think I'm going to move on from this question. There's a question in the chat on one of the homework questions that I totally want to go over. Question before we move on. Yeah. Mm-hmm. Correct. So if we want to stick with, if that factored form is going to match with what we originally started with, it's only going to be equal as long as we keep that X with us. Yeah. Okay. So I'm not sure I don't know which number this is from the homework, but this is one of the homework problems. So we've got 18x squared minus 32y squared, and our instructions are to factor completely. Oh, number 10, thank you. So I kind of have a hint that this is probably something to do with perfect squares because of the x squared minus y squared, and like there isn't a third middle term in that. But no matter what the problem is, I'm going to start by looking for the greatest common factor that I might be able to pull out of all the terms. So here, 18x squared and 32y squared. 18 and 32 don't have much in common, but they definitely have a 2 in common. So if I pull the 2 out first, then this turns into 9x squared minus 16y squared. And now we can use that perfect squared formula. My guess is that if you just don't think about the problem too hard, you've probably been factoring with that perfect squared formula for a while. Don't fight your instincts. You do not have to write a formula. If you just already kind of have this gut feeling and it's right, go with that. If I do this slowly so that we can like apply the formula, I'm going to think about that 9x squared as saying 3x squared and the 16y squared as saying 4y squared. So that we've got 3x minus 4y times 3x plus 4y. Okay. Dun, dun, dun. Are there other questions from? Oh, okay. So, question in the chat. This only works because it's a difference. That is correct. When we're talking about perfect squares, it only works if we have subtraction between perfect squares. But when we have addition between perfect cubes, there is a factoring rule for that. And we didn't go over that Wednesday. Wait, today is Wednesday. We didn't go over that Monday. I asked everybody to read that part of the book, but I can just give you the formula really quickly. So when we have perfect cubes and we have addition, this does have a formula, which looks almost like the formula we did talk about the other day for subtraction of perfect cubes. And because the formulas are so close, sometimes what you will see in a textbook is they'll combine these two formulas together by using the notation. If I can get my pen to wake up this morning, by using this notation. Where we kind of read the formula across the top, if it's a plus, and read the formula across the bottom if it's a minus. Don't have to, I just wanted to show people that sometimes that's how the formula will show up in the book. There's a request to take a look at 24. So give me a second because I don't have it pulled up, I don't think. But I will get it pulled up. It's trying to load, you know. Oh, okay. So the question about 24, that's what I was wondering. So we actually haven't talked yet about that chunk, about that 5.7 stuff. So that's actually what we're going to go over today. So hopefully we'll have an answer to 24 by the end of the day. So let's roll into new stuff. And then if I've got time, I'll come back and talk about 24. I'm going to do something in secret over here. Okay, I've got a number that's covered up right there. Oh, okay. It'd be helpful if I actually had it on the screen. Good call. Okay. I've got a number that's covered up by, I don't even know what that is. And when you multiply it by 5, the answer you get is 0. What number did I cover up? There's no other number that works in there? Nah, it's not a trick question. It really is 0, right? The only thing that works if I've got 0 times 5 is 0. Ready? I'm going to do another one. I got a number under there. And when I multiply it by -2/3, I get 0. What number is under my little thing? Yeah, it's not a trick question. If I have two things multiplied together and the result is 0, then I know that one of those two things had to be equal to 0. That is at the heart of solving most algebra equations that we're going to encounter from here on out. That is not going to make sense in anybody's notes later, so I hope you didn't do that. So my instructions here are just going to be to solve for x. If I told you that I had x minus 3 times x plus 4, and that whole thing was equal to 0, I have two things multiplied together and the result that I get is 0, which means one of those two things had to be equal to right. So this tells me that either x minus 3 is equal to 0 or x plus 4 is equal to 0. So I'm going to get two answers. X could be 3 or x could be -4. If this were a question, if it's already factored and it says it's equal to 0, you do not have to show me any work at all. If you can do that in your head, you're just going to write x equals 3 or -4. Totally, completely fine to go straight there and write nothing else at all. One more straightforward-ish one. 2x plus 1 times 3x minus 5 is equal to 0. If my instructions are to solve, and if you can do this in your head, it is totally fine to just write down the answer. X could be I know, because we love fractions. So don't be afraid of the fractions. You can work it out on your paper. You do not have to work it out in your head. But you do have to be able to turn that into two answers for x values. If you're joining me on Zoom, you can put your x values in the chat. I'll even switch it so that you can only chat with me directly. I'll give everybody a second. Both answers should be fractions. I've got one brave answer in the chat. I've got several x equals -1/2 coming through in the chat. So if I'm solving this one, right, I can subtract 1 from both sides and then divide by 2. So there's that -1/2. And on the next one, if I add 5 to both sides, I'd have 3x is equal to 5. And then we want to be careful. I need to divide by 3. So I'm going to have 5/3 or 5/3. What I hope is that after you do a bunch of problems, this one becomes a quick one that you can just write the answer down without having to do work. And by the time you're taking calculus, that this one becomes something that you can write down without having to do work. Let's get some more practice. I'm going to go ahead and flip the page. Pausing for questions. Not seeing questions in the chat or the room. Okay. Most of the time, the problems are not going to start quite so nicely for you. Most of the time, you're actually going to start with something that maybe looks like, how about x squared minus 5x plus 6 is equal to 0. And I'm going to look at that and say, I wonder if I can turn that into two things that are multiplied together. Because if I can, then I'll be able to solve for it being equal to 0. And the only way I know to write that as things multiplied together is to factor it. So step one, we're going to need to factor. I will give you all a minute to get that part done. Factor it on your paper. You got this. I need to drink of water, so I'm running outside real quick. I don't know if I mentioned this, if I have mentioned this since we've been talking about factoring. Personally, I find the X method really helpful when the coefficient on the X squared is not 1. But if the coefficient on the X squared is 1, I usually just go straight to thinking about my possible factors. Because if the coefficient on the X squared is 1, then basically the two methods come down to doing the same thing, thinking about the possible factors. So I know that I need an X and an X. I need two things that multiply to give me 6. That plus sign tells me they have to have the same sign. That minus sign tells me they're both going to be negative. So I really don't have a choice but 3 and 2. Which means that we're going to set each factor equal to 0. And I'm going to have 3 and 2 as my answers here. Totally tempting to think about 6 and 1, right? Because if I have a 6 and 1, I can definitely get a -5 from a 6 and 1. But because of that +6, they have to have the same sign. So if you're going this method of checking the factors, it is really useful to think about what the signs of the factors are going to be. Okay. Question.
So just like as the X equals 3 and 2.
Yep.
Since you wrote them as like negative.
So the two pieces that go into my factoring were -3 and -2. But when I'm solving x minus 3 times x minus 2 is equal to 0, it means that either x minus 3 was equal to 0 or x minus 2 was. And when I solve these, right, I'll end up adding 3 to both sides and getting x equals 3, or adding 2 to both sides to get x equals 2. I'm just doing this step in my head. You don't have to do this step in your head. You are totally welcome to write it down. Okay, speaking of writing things down, don't write this down because we're playing more games with my strange little thing. Okay. Okay. I have a multiplication problem underneath my widget. Anyone know what multiplication problem I have written under there? I multiplied two things together and I got 6. Which one is it? 2 times 3 or 1 times 6? What do we think I have under there? Would you bet your financial aid package that you're right? Heck no. Because I could have a whole lot of things written under there. I could have 2 times 3. I could have had 1 times 6. I could have had 5/3 times. Now I got to do math times 18/5. And that would have also equaled 6. The only way that this magic with factoring works is because of 0. 0 is the magic number for factoring. So if I don't have a 0, I have to get one. Let's say that I had something that looked like, how about 4x squared minus 8x. No, how about 4x squared minus 9x is equal to -2. It could be tempting to look at the left-hand side and to like factor out an x. But if my instructions are to solve this, I know that in the previous problem, I said that the first step was to factor. There's actually a step 0. And I call it step 0 because we need a 0 on one side. Of the equal sign. Then we can do step 1 and step 2. But my first step is step 0. So in this case, I'm going to add 2 to both sides. So that I've got 4x squared minus 9x plus 2 is equal to 0. Now I can move on to get it factored. I'm going to let you all get that factored, but I will help you get the x set up. So I'm going to use an x because my coefficient on the x term is not 1. So what goes on top is going to be 4 times 2 to give me the 8, and I'm going to put a -9 at the bottom. I need 2 numbers that multiply to give me +8 and add up to -9. Awesome. A couple people in the chat have given me -8 and -1. Those look like they're going to work. So I will let you all do the factoring by grouping. if your son wants to go straight to the factors, you go straight to the factors. You do not have to do this X stuff. Just help me organize my thoughts. I can tell, you're good with action.
That's how I'm like, what are you doing?
Yeah, it's totally fine, you can
Okay.
go straight to the factors, don't have to do the X thing, don't learn new stuff. Like if you've already got skills, don't unlearn things. Roll with it. I want to make sure that we have time to get to that homework question that someone asked about before. So I'm going to go ahead and get this rolling together. So if I'm doing the factor by grouping, I'm going to look at those first two pieces and say, what's the greatest common factor? What do they have in common? Looks like they have a 4 and an X in common. So if they've got a 4 and an X in common and I pull that out, then I'm going to be left with X minus 2. This is another case where in the second part, because I'm trying to get this X minus 2 to match up with the second factor, I'm going to need to pull out a -1. Whole thing is still equal to 0, so I'm not going to lose sight of that. But now, these both have that X minus 2 in common, and when I pull that out, the first piece has a 4X and the second piece has a -1. So now I'm ready for step 2, because it started with step 0. And step 2, we're going to set each factor equal to 0. Well, if X minus 2 is equal to 0, then X is going to end up being 2. And if 4X minus 1 is equal to 0, I'm going to get an X value of 1/4. There's a question in the chat to kind of rewind to me pulling out the -1 part. So let me just cover up the bottom so it's not in the way visually, and then I'll uncover it again. So the whole idea with factoring is that if I were to multiply the number back in, I should get back what we started with. So if I take that -1 and I multiply by X, I get the -X. Sorry, my shadow is kind of covering things up. And if I take the -1 and I multiply by +2, sorry, if I take the -1 and multiply by -2, I would get that +2 back. So it's all about like thinking through the multiplication in reverse. So when I pull out that -1, I'm kind of thinking backwards through the multiplication step. Cool. So our answers are 2 and 1/4. Now, let's say that you're working through these problems and you're working through problems that you don't have the answers for. You can always plug the values back in to make sure that when you plug them into the left-hand side, you really do get -2. It would also be excellent practice for getting common denominators with fractions if you were feeling like you wanted extra practice. But you do not have to show me your work like checking these. If you want to do it, you totally can. Okay, I think we have time, and now I'm gonna scroll back up in the chat. I think it was problem 24. It's up there somewhere, yeah, problem 24. Okay, so let me grab problem 24. And problem 24 says y cubed equals 9y. Y cubed equals 9y. Yep. Okay. So my step 0 is to get a 0. I'm going to take that 9y and subtract it from both sides. Now I get to move on to step 1, which is to factor. So I'm looking for the greatest common factor. And these both have a y. And when I pull out a y, ta-da, now I am left with a difference of perfect squares. Since I'm left with a difference of perfect squares, I already know that that's going to factor as y minus 3 times y plus 3. And we haven't actually done one like this, so it's awesome that this gets to be our last one. Now I move on to step 2, which is to solve each factor equal to 0. Don't forget about the y out in front. This is a factor also. This says y could be equal to 0. Or y minus 3 is equal to 0. Or y plus 3 is equal to 0. So my answers are going to be y equals 0 or 3 or -3. And my clock says it's 9:50, so I think we are out of time. I'm going to stop the recording.